achieve narrow bandwidth, what are the options? So first we are adding reflector. Okay, if we are adding reflector, then the aperture area, what is going to happen by adding reflector? The aperture area is increasing. Now सेकेंड हम लोगों ने क्या किया, डायरेक्टर्स, आपने क्या किया, डायरेक्टर्स ऐड करना स्टार्ट कर दिया. सो बिकॉज ऑफ डायरेक्टर्स डायरेक्टिविटी इज इंक्रीज. बैकलोब, दिस इज वेरी इंपॉर्टेंट. बैकलोब क्या हो गया, जो डाइपोल में बैकलोब आता था आपका, वो क्या हो गया, आपका पूरा का पूरा चला गया. मतलब अगर आपको याद रहेगा कि दिस इज योर डाइपोल एंटीना कैरेक्टरिस्टिक्स. ओके, बट वही डाइपोल एंटीना यू आर यूजिंग विथ रिफ्लेक्टर इन अ यागी उड़ा, आपका जो रेडिएशन पैटर्न है वो क्या हो गया, इट इज लाइक दिस. ओके, सिर्फ आपके छोटे छोटे बैकलोब आ गए. राइट, अब अगर आपको इसमें और इम्प्रूव करना है एंटीना की डायरेक्टिविटी, तो आप क्या करोगे, करेक्ट ड्रिवन एलिमेंट्स. वेरी गुड. तो अब मुझे बताओ कि आपको क्या चाहिए. सो द फर्स्ट थिंग इज व्हाट इज एन अरे. सो ऑल इंडिविजुअल रेडिएटर्स, अगर आपने वो एक सिमिलर फैशन में अरेंज किए. नाउ व्हाट इज अ सिमिलर फैशन, दैट मीन्स distance between the two array. Okay, then what is going to happen? So first of all, radiation pattern is depend on what, आपका जो radiation pattern है, the first relative position of your dipole, or now in this array case radiator. Second and very important, what is the phase difference between these radiators, or what is the relative phases of current fields of them. Because when we are studying one antenna, हमें कोई जरूरत नहीं थी कि उसका फेज शिफ्ट क्या है, because we are directly calculating current. Okay, and we are just giving a comment what is a polarization, vertical, horizontal. Okay, but now when we are placing the various radiators, तो क्या होगा, फेज शिफ्ट क्या करता है, एक दूसरे को कैंसिल भी कर सकता है, एक दूसरे में ऐड भी हो सकता है. So this is very important. What is a relative phase shift of the current? Now what is the third factor? Third and very important factor is what is the magnitude. मतलब एक है आपका imaginary part, दूसरा है आपका real part. So real part magnitude is going to actually decide the power factor, because power formula is a magnitude. If you remember the electromagnetics, or if you remember the main formula, pointing theorem. So in a pointing theorem, we are interested in a magnitude only. Okay, so what is a magnitude is going to decide your power. So third and very important point is a relative magnitude of individual radiator current of fields. Now why only radiator current? Because what is the power formula? Power is equal to I square R. So your resistance is what? Your resistance is, what is your resistance? It is nothing but radiation resistance. Now this radiation resistance is a constant or variable? Very good, constant. Very good. Why it is going to be a constant? Because the first step, design an antenna. When you design the length of an antenna, when you design the material, when you design the shape of antenna, लाइफ लॉन्ग ये कोई भी कैरेक्टरिस्टिक्स चेंज नहीं होंगे फॉर एंटीना. सो दैट्स व्हाई द रेडिएशन रेजिस्टेंस इज अ कांस्टेंट. नाउ व्हाट इज अ चेंजिंग पैरामीटर? अब इस फॉर्मूला में चेंजिंग पैरामीटर क्या है, इज योर करंट, एंड करंट इज डिपेंड ऑन एंटायर दिस थिंग्स. व्हाट इज द पोजीशन, फेज, एंड आपका रेडिएटर कौन सा है, कितने आपने रेडिएटर कनेक्ट किए. ओके, so that's why this is very important, that what is a relative magnitude. And the fourth point, and it is very important, that pattern, what is the radiation pattern for individual radiators. Okay? But if I choose dipole as a radiator, so what is the actual ideal dipole characteristics? that it is a back lobe and front lobe. Okay, it is already shown here. So this is the actual characteristics. If you want to change these characteristics, so हम लोगों ने क्या देखा, यागी उड़ा में फ्रंट लोब इज देयर, आपका बैक लोब था वो आपने मिनिमाइज कर दिया. ओके, so this is very important. What is the basic radiation pattern of your reflector? Then you can comment on the what is the changes. Okay, note down these 4 points or take a screenshot. It is okay. So now, before starting practical array to isotropic element array. So if you remember, when we started antenna, the first antenna that we are studied is a isotropic. Why? Because ideal antenna, and if you first design the characteristics of your ideal antenna, then it is easy to design the characteristics of your practical antenna. Or what are the assumptions? What are the actual characteristics we want from an ideal? What is the difference between practical characteristics and how to minimize that difference? So this is the main 3 steps that required in an antenna. First, you have to understand what is a ideal, then what is a practical, and third step, how to minimize the difference between ideal and practical antenna. So now the simplest way how to arrange 2 isotropic point source radiators. Because what is the isotropic? Isotropics means what? This is a simple one point source. Okay. Now similarly, the second, what is the simple way to arrange these 2 sources? Before starting this, there is a one concept is a coherence, spatial coherence and space और टाइम कोहेरेंस. अपने फिजिक्स या फर्स्ट ईयर में स्टडी किया है कोहेरेंस. ओके, नाउ इमेजिन दैट यू ऑल आर सिटिंग इन your lecture hall. Okay, and from lecture hall you get a message that you all have to visit library at 1 p.m. to collect some book. In your class, if 60 students are there, okay, so 60 student, and at 1 p.m. dot 1 p.m. all 60 students are present in library. So this is a time coherence, means all particles or all waves or whatever small जितने भी वो डॉट्स है, आप उसको डॉट्स में इमेजिन करो. यू इमेजिन इन अ पीपल, यू इमेजिन इन अ ऑब्जेक्ट, यू इमेजिन इन अ चॉकलेट. ऑल आर गोइंग टू प्रेजेंट one instant at one particular place and at another instant on another place. So this is a time coherency. This is very important in communication when we are receiving any data, any signal. That is it possible that every signal, electromagnetic waves, what we are transmitting, can we collect in the same time some another space? Because the main problem is a multipath fading. Okay, now what is a multipath? That when electromagnetic wave is going to, if there is a building, if there is a tree, what is going to happen? Your signals are going to reflect and the reflection angle is not in your control. So there is a phase shift. Okay, so this is the second coherency. Now what is the second coherency? Second coherency is that if we are transmitting a X signal or X electromagnetic waves in a 30-degree angle and I am transmitting it at a B place. At a B place, can I receive the signal with the same phase shift? Means if this antenna and this antenna is equally spaced, okay, now this is going to transmit, okay, again the same way. This is a second wave. So if this phase shift and this phase shift is equal or different, this is A and this is your B isotropic antenna. So now tell me what is going to happen. 2 antenna are going to radiate the electromagnetic waves and your observation point is somewhere here. What is going to happen? You are observing water, okay, और जब वाटर का जो सरफेस है उस पे कोई लाइट गिरता है, ओके, और आप जब उसमें देखते हो तब आपको क्या लगता है? यू आर फाइंडिंग दैट ऑब्जेक्ट इज अ स्टेबल. किसी ने ऑब्जर्व किया या आपको ऐसे नहीं लगता कि वो ऑब्जेक्ट मूव हो रहा है? सो दिस इज वेरी इंपॉर्टेंट दैट the meaning of term phase as applied to the radiator elements of an array, आप कैसे उसको कंसिडर करोगे? At some distance point, the fields of two radiating elements as shown in figure are examined. अगर मैंने P point से उसको examine किया, this is my P point, यहाँ से मैं क्या करूंगी? इसको observe करूंगी. Okay? इसको भी मैंने P point से observe किया. Okay? So what is going to happen? This is my observation point. Okay? So we found that at some distance point, the fields of two radiating elements are examined and found to be in phase with each other. उन दोनों का जो phase है वो same है. If then the phase of current radiated to is changed by amount alpha radians. इसका जो phase shift था first A का it is unchanged, but B का जो था वो क्या हो गया? कैसे जाना चाहिए था वो एक्चुअली इन दिस वे, बट ऑब्जर्वेशन पॉइंट से मुझे क्या मिला? देयर इज अ फेज शिफ्ट ऑफ अल्फा रेडियंस एंड फेज ऑफ अ करंट इन रेडिएटर 1 इज अनचेंज्ड. देन सेकंड ऑब्जर्वेशन इज द टू फील्ड्स एट द डिस्टेंस पॉइंट आर नाउ out of phase by the amount alpha radians, and the phase of radiating element in an array is always discussed in relation to the phases of each other elements. If the phases of two radiators in the two element array are changed by the same amount, the array pattern is unaffected. आपका जो radiation pattern है, it is not going to change, but changing the phases between the two elements affects the way that individual fields of the two radiators add up at the specified distance point. So now what is going to happen? If this is an isotropic antenna, okay, or for our convenience, rather following isotropic, if we observe that it is a dipole antenna. So what is going to happen at observing point if I place one dipole here and another dipole at a B position? What is going to happen? Because in Yagya-Gouda we applied this. If we are increasing the dipole, what is going to happen with your radiation pattern? Directivity क्या हो गई? Change. Very good. लेकिन कैसे change हुआ? Your directivity is increased. Okay. Now, अब ये जो डायरेक्टिविटी आपकी इंक्रीज हुई विदाउट अ फेज शिफ्ट, क्योंकि अगर फेज शिफ्ट होता है तो क्या होता है? आपका बैकलुक जो है वो इंक्रीज होना स्टार्ट हो जाते हैं. ओके, सो अब आपको क्या करना है? इफ यू वांट टू डिजाइन अ अरे, अब मुझे बोलो आपको क्या चार चीजें हैं जो आपको परफॉर्म करनी है. इफ यू वांट टू डिजाइन अरे बाय यूजिंग डाइपोल, if you want to design array by horn antenna, if you want to design array by using microstrip antenna, if you want to design array by folded dipole antenna or any antenna, basic antenna जो है, तो अगर उससे आपको array डिजाइन करना है तो आपको कौन सी चार चीजें हैं जो बहुत ज्यादा इंपॉर्टेंट है? These are the four. First, आपका individual radiators क्या है? Okay, then उसका relative position, then relative phase, then relative magnitude of individual radiator, okay, and your pattern for individual radiator. But pattern is not going to change क्योंकि आपने एक बार डिजाइन कर दिया, उसका पैटर्न एक ही रहने वाला है. सो मेनली पोजीशन, आपका जो पोजीशन है, हाउ यू आर गोइंग टू प्लेस द रेडिएटर्स, it is very important in a design of array antenna.
For more information of this topic, don't forget to subscribe my channel Pinnacle.